giving any of you guys pictures. I gotta trust you guys enough yet. Jeez. What? Please. Like, I was never a student who was mean to the teacher. I don't need that in my life. I don't need that in my life. All right. Hush. Okay. We are going to do one of these. Maybe two. Maybe two. All right. 20. I know that we're going to do 29 automatically. 26. 26? Anyone else for 26? 26? Any? Okay, give me one more. 23 or 22? 23. I heard 23, sorry. I'll show you real quick on 22. Well, I'll talk fast about 22. Okay, again. Here's the intention when I'm going over homework, like these first few problems. The intention is that you can follow along with what process you already did and find, hopefully, the smaller error that you made. The intent is not that I'm really teaching it to you for the first time. I would never explain something that fast as I'm about to, okay? Just so you know, all right? So hopefully, like, if you didn't do your homework at all and you have no idea what the problem's about, it's going to feel like, what are you saying? All right? But hopefully, you've kind of done it. You talked about it in your table. You have a good, like, insight into the problem already. Okay, so I'll talk about 22 super fast, but then we'll talk about the other ones. You have this square and circle situation. All right, 22 has squares and circles. It tells you this whole thing is 100 feet, and you're trying to find the area. Most of us got pretty quickly to, from what I saw, that this would be 50. Don't care. And this would be 50. So that this is going to be 250 square inches. Okay. So we got that. We got that those two squares are 2,500 square inches, or that these two things together have an area of 5,000 square inches, okay? We're okay with that part. The part that was a little trickier was finding out these quarters of a circle. Technically, if we could kind of visualize, right, if I swapped these two, then these two pieces would make a half circle, right? They'd make a half of a circle or a semicircle out of those two pieces, okay? And I also know that if this part is 50, if we're cool with that part being 50, then this bottom section has to be 50 as well, which means that's the radius of my circle. Okay, this radius right here is 50 inches for the circle. So you're trying to find, I'm going to go ahead and join the two of those and say they have a radius of 50 inches, and so I'm finding the area of half of that circle. Half of the circle with a radius of 50. I know the area formula for a circle is going to be r squared times pi. And since my radius is 50, that's just going to look like 50 squared times pi. On my calculator, 50 squared means 50 times 50. So you can either use the squared symbol and get 50 squared, or you can just type out 50 times 50. Right? Either way you do it, you get 2,500. That's 50 squared. And then I'm going to multiply that by pi. So I'm going to have 2,500 times pi. If you're using those bigger calculators, the pi symbol is above the division symbol. You've got to press second to get there because it's a different color, right? So you've got to press second pi. Those are the two buttons right there. To get the pi symbol, I'm going to want you to use the pi symbol from now on because it's more exact. Okay? So that's the area of the entire circle. Right? That's the area of the entire circle, but we know we only want half, so I'll divide by 2, and I'll get that the area of those semicircles is 3,926.99.7. So I have this, and this, and when I add them together, I get my total of 8,927 square inches. Okay. All right, that's 22. Moving on to 23. That was the other one, right? 20. We're doing 3. We're doing quick. Blah 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 blah. 111. 8 feet by 16 feet. Ah, I see. Okay. Let's do it this way. You know that the tiles are 6 inches by 6 inches. Yes? Yes. What's the area of the tiles in inches? Awesome. The area is 36 square inches. So we need our units to be the same. So what I'm going to do is I'm going to turn this into inches. Are you trying to find pi on there? I'll fix that calculator later. Maybe for you, but that's not how I'm doing it, okay? I'm turning it all into inches, so I know that 8 feet, there are 12 inches in a foot. 12 inches in a foot, so 8 feet is 96 inches, okay? So this is going to be 96 inches. Do the same thing for 16 feet. 16 feet into inches by multiplying by 12 is 192 inches. So that I'm going to use those guys to find the area of the entryway. Area of my entryway is 96 times 192 is 18,432 square inches. So if each tile covers 36 square inches, and there's a total of 18,000-ish square inches, if that's how many square inches I need to cover, and each tile covers 36 of them, I just need to figure out 4,000, whatever that is. Oh my gosh. I can't handle that. I can't handle it. It's okay. Divided by 36. So if I do that, 18,432 divided by 36, I get my answer of 512 tiles. Okay, 512 tiles. All right. Okay. Last one, we're going quick. Oh, Melissa, classic. That crazy home. Okay. Oof. All right. 26. 2 different things. The first one we're going to do is the Italian buff tile at $6 each. 1 foot. Italian buff covers 1 square feet. 1 square foot per tile. That's the Italian buff tile. And she's putting it in her entryway and kitchen, right? She's putting it in her entryway and her kitchen. When I look at this, I could do it I'm going to do it this different way than I did the first time. Okay? That's what it looks like when my math is not for you, just in case you're wondering. Entryway and kitchen are going to be Italian buff tiles. I can see that the kitchen is 8 feet wide, and together with the length of the living room, this is 30 feet. So she's going to cover a total area with the Italian buff that is 8 feet by 30 feet, which is 240 square feet. So she's going to cover 240 square feet with that tile. Each tile covers 1 square foot. So how many tiles does she need? Thank you. Oh my gosh. She needs 240 tiles at $6 a piece. At $6 each. $6 per tile. That's 240 tiles times $6. That gives us a lot of money. $1,440 for just that part. The second thing that she's going to do is in the bath with the ceramic tiles. She's also going to ceramic tile the bathroom. The bathroom had dimensions of 12 feet by 14 feet, which gives us 168 square feet, going quickly by multiplying. The problem here is that she's going to lay 3-inch tile. Okay, let's do it that way. We'll do it the same way we did the last problem, just to keep it the same. She's going to lay 3-inch square tile. Just turn it off. Just stop. I don't care. It's not a conversation. She's going to use... I shouldn't have done that. trying to do that. She's going to use 3-inch square tile, which covers 9 square inches. So we're going to do the same thing that we did in the last problem to figure out how we're going to turn these into inches and say that's 144 inches. This guy's 168 inches. I would find the area in square inches. Okay, that's the area of the bedroom or of the bathroom in square inches. You know each tile covers 9 square inches. You go ahead and divide to figure out how many tiles you need. Okay. Find out how many tiles you need. At 95 cents per tile. Gives you a total cost of $2,553.60. So when you add those guys up, when I add these up, I get my total. Whew, the end. Oh my gosh. Okay. So much talking. For again. Ugh. For issue, we all need rulers. I'm not going to do problem 26. We're going to talk about something else, and then we'll do problem 26. Okay? 29. Sorry. Don't worry about it. We need rulers. We need rulers. All right. You have something in front of you. Here's what I need you to do. Hey.
This kind of looks like my house.
I said okay. I said okay. I said okay. I need to know what 1 inch, how many, wait. Is that what I want to know? What do I want to know, Hershu? For scale. No, for scale.
Yeah.
I want to know what?
Well, what each foot is?
On here.
That's your inch per foot.
Okay, I want to know how many inches on your ruler. I want to know how many inches on your ruler represents 1 foot on here. I want to know how many inches on the ruler, or fractions of an inch, represent a foot on here, on the plan. See if you can't reason through that with your team. Reason through that with your team. It's like an eighth represents a foot. Yeah. Right? The first thing we need to be able to do is read plans. This is your first time even having plans in front of you. Okay. Did anyone have any questions about, like, if I was going to measure the living room? Hopefully you could get to which way was 23 feet and which way was 14 feet. Hopefully, right? Hopefully. We can see that the 23 feet is long and the 14 feet is shorter. But now here's a question. From where to where is 23 feet and 5 inches? Kenji? Right. Do I measure from here to here? Do I measure from here to here for 23 feet? Do I measure from here to here for 23 feet? Maybe. Do I measure from here to here? Do I measure inside? Okay. When I'm talking about this, the dimensions are the inside of the building, right? It's the inside of the room. I don't care how thick the walls are. That does not play into the square footage of the room, okay? So as you're measuring this living room, I want to measure it from this very edge right here, all the way to the end, to the inside wall, right? So I'm trying to go to the inside wall. And how far do I get? I'd say that 4 4/16, which simplifies to 4 1/4. Okay, so I have that 4 1/4 inch is representing 23 feet and 5 inches. Right? But I want to know how much of this represents 1 foot. Okay? That's what I'm trying to figure out. So, if I know that 4 1/4 inches represents 23 feet and 5 inches, your first step is to turn both of these into full decimals. You can't add fractions in your calculator. So I need you to turn 23 feet and 5 inches into a decimal. That's your first step. As your team, decide how to do that. And it's not 23.5. Right now, how do I turn 5 inches into a decimal? Don't be distracting, be productive. 5 inches is how many parts of a foot? Or how many parts are in a foot? I don't know. What am I asking? 5 twelfths, right? This would be 5 inches out of 12. So if I want that into a decimal, I need to do 5 divided by 12. Okay? I need to do 5 divided by 12. So 23 feet and 5 inches is really 23.42 feet. Right? It's 23.42 feet. Okay. This next one maybe is a little easier. How do I turn 4 1/4 into a decimal? Say louder. Right? So I really have this. Hold up. So I really have 4.25 inches for every 23.42 feet. I have 4.25 inches for every 23.42 feet. So that means if I divide those two things, if I divide 4.25 divided by 23.42, this tells me that that's how much of the inch represents 1 foot. This means that 0.18 inches represents 1 foot. Now, can someone show me where 0.18 inches is on this ruler? 0.18 inches, anybody? I have no clue. This is not how we learned rulers. Notice Mr. Rishu didn't get up here and be like, this is 0.25. This is 0.5 of an inch. This is right. He gave us, what did he give us when he taught us about rulers? Fractions. What's the smallest fraction we work with on the ruler? 16ths. So if I want to know how many 16ths that is, what maybe should I multiply by? 16ths, right? So I have that number, inches. And if I multiply it by 16ths, round that for me. How many 16ths is that going to be? 3, right? So this means, which is about 3/16 of an inch. And what that means then is that our scale now is 3/16 inch. Ooh. How do I write it? A line equals 3/16 of an inch represents 1 foot. So on your ruler, on these set of plans, right here, 3/16 represents 1 foot. Okay? 3/16 represents 1 foot. So, tell me, write this. If I had something that was, if I wanted to draw like a 2-foot wall, if I wanted to draw that, how long would I draw a 2-foot wall? How many 16ths would it have to be? 6/16, right? Because 3/16 represents 1 foot. So if I wanted to draw a 2-foot wall, it should be 6/16. And a 3-foot wall would be how many? 9/16. Right? Each group of 3/16 represents 1 foot. Okay? Now, with that being said, I want you to go back to number 29 in your homework. Back to number 29 in your homework. And I want you to do this individually right now. Individually. Individually means you aren't talking, because some of you right now are right on the cusp. You're like, oh, okay, I get it now. And I want you to have some brain space. Okay? So I just want you to work for like a minute or 2 minutes on your own to see if I can't redo that again. Can I measure it and compare the actual measurement to the scaled measurement? Okay? Here's the hint for you. Really what you're trying to do is you're trying to get the actual measurement divided by the scaled measurement. What does it actually, right? Ruler versus plan. What's the ruler measure? What do the plans say it should measure? Those are the two things you're trying to divide. Okay? I want to know for number 29, the scale. Jerry, did you have a question for the whole group or for you? Okay. You have 29 on your homework, Chuck. 29 on your homework. Scale. We're going to continue working on scale. Guess what? Your first day seeing something, you're not going to master it, right? We will continue working on it. Okay? What we're going to do right now is the quickest notes you ever took. I like to give you quick notes.
You do that every time.
I know. Just watch. Stop talking. Do not talk. A 3D shape. Okay? Essentially, you know about area and perimeter for 2D shapes? Surface area is kind of like perimeter's 3D cousin. Okay? So on these different prisms on your table, right, if I'm looking at this one here, oh my gosh, right, the surface area of this is going to be the area of each of the faces, right? So there's a triangle there, there's a triangle on the other side of it, boop, and then there are 3 of these faces. There's 1, that's a rectangle, 2, 3, right? So the surface area is just all this parts that I can touch. Okay? Basically all the area of all the parts that I can touch. Okay? The area of each of the sides of the 3D shape. Okay? We're going to talk about two different kinds of shapes. And here we're going to deal with prisms. What's the word congruent mean? Awesome. It means the same. Two congruent bases with rectangular sides. So, examples of prisms. They are named for their base, right? This that I was just showing you is a prism. It's a prism. And what's the base shape? What's the base shape? Right? A triangle. So that's a triangular prism. Right? If I have something like this guy, right? This is a prism as well. Might even say it's a cube because it has two congruent bases. There's the base. And what's the shape of the base? Rectangular, maybe square if we measured it. We're not sure. Okay? Notice though how the triangular prism is different from the triangular pyramid. Right? The triangular prism is different from the triangular pyramid. Okay, so we're going to talk real quick about the pyramid then. A pyramid has one base with triangular sides. You might have a base that's a rectangle. Right? You can have a rectangular pyramid, but it has triangular sides and just one base. Now, when those prisms or pyramids have a circular base, they get a special name. So if I have a prism with a circular base, what's that called? If I have a prism, right? If I have a prism with a circular base, what's that called? Awesome. The cylinder right, has a circular base. So when I'm trying to calculate the surface area for a cylinder, it's going to be the area of the circles, which we already know how to find, plus the area of the side. I guess. There's kind of only one side. Okay. So, we'll look more at this formula. We'll look more at this. But I'm going to tell you, what's the area of the circle? What's the area of a circle? Pi r squared. Some of you are used to saying that. R squared times pi. How many circles are there? Two. So for the circles, I'm going to have two of my r squared pi situations. All right, notice I'm adding the r and the h for the radius and the height of the cylinder. The area of this side piece, and we're going to continue to look at that, is going to be the height times 2 pi r. Okay, it's going to be the height times 2 pi r. We'll talk more about that formula in a bit. More. Okay. So what's the name for a pyramid with a circular base? Boom, right? There it is. The pyramid. Ooh, let's see that. There we go. The pyramid with a circular base is called the cone, and I'm going to give you the surface area for a cone. Again, circular base. Your cone drawing skills are going to get baller. Cones have a radius and a height as well. And the surface area for the cone has a height, and it has this L, which we are going to call the slant height. And I need you to notice the difference between the height and the slant height. Cones get a little bit weird, and the surface area for a cone is, again, it's going to be the area of all the pieces that I could touch, essentially. We know that there's the base. How do I find the area of that base? Right, r squared times pi. But I also need the area of this slanty stuff here, and that stuff's a little bit harder to find. But it's going to be plus pi times r times L, where L is our slant height. Okay, so keep that one in mind. All right. All right, you can leave the rulers and prisms on your table. Have 30 through 34